Okay, we're still in the chapter 1 notes here, so I'm going to pick up with this definition. It says, in many studies, typically more than one variable is recorded per case or individual. It's often the purpose of the study to determine if and or how one or more of the variables affect each other. A response variable is a qualitative or quantitative variable that represents the outcome of the study. It's our variable of interest in predicting or forecasting. And an explanatory variable is any variable that would explain the response variable. Okay, so as an example, suppose that we look at this one here, heart surgery and survival time. Says that a study is performed by a medical center to determine which of two heart surgeries is most effective. Angioplasty, which is running rubber tubes through the arteries, or bypass, which is rerouting the arteries. The purpose of either procedure is to prolong the life of the patient. Okay, and the survival time of each patient, measured from the time of the surgery, is recorded. Okay, so suppose that we want to identify the response variable and the explanatory variable. The response variable would be the most important variable in the study, okay, and that would be the survival time. How long did these people live, okay, after their surgery, okay, so it says that the response variable, that's the most important variable in the study, since it represents the outcome from which each type from each of the operations. Okay, and if we want to know the explanatory variable, the explanatory variable would be anything that would explain the response variable. Okay, so the entire purpose of the study is to see if we can use the type of operation to predict the survival time. Therefore, the type of surgery is the explanatory variable. Okay, and as a note, it says in a true clinical trial, many more explanatory variables would be recorded. Okay, there's many things that could explain, like how long somebody lived. Okay, so gender, age, type of surgery, the state of the health pre-surgery, just to name a few. Problem 22 and 23, we want to determine which variable is the explanatory variable and which is the response variable. Okay, in problem 22, it says the temperature of a pot of tea compared to the height of the flame underneath the teapot. Okay, so the response variable would be the most important part of the problem, okay, which would be the temperature of the tea. Okay, now what would explain the temperature of the tea? It'd be the height of the flame. In problem 23, the number of hours you work compared to your paycheck. Okay, the response variable would be the amount on the paycheck, and then anything that would explain that would be the number of hours that you worked. Okay. One of the things that we got to be careful with when we sample is any biased sampling. Okay, and it says that a biased sampling method is a method in which preference is given to selecting some individuals over others. It could also mean that certain responses are more likely to occur in the sample than in the population. Unbiased sampling is one that is not biased. Okay, and by the way, we like unbiased sampling. Okay, we want to be as random as we possibly can whenever we go out and get any sample. Okay, so just to give you an example here, suppose that we wanted to know the proportion of Americans who consider themselves baseball fans. Okay, so what if we stand outside of Wrigley Field, and we ask the first 100 people that come up to the stadium there, do you like baseball? Okay, and then we get our sample, and then we can continue our research. Well, the problem with that is that the individuals selected are not accurately going to reflect the makeup of the entire population. Okay, since pretty much anyone that would be around Wrigley Field would be, somewhat interested in baseball. Okay, so a better way to do it is to don't go to a place that has a baseball field there. Or, maybe go to a neutral site. And do the sampling there. Okay. That way the results aren't going to be skewed one way or the other. Okay. Here's some more examples. Determine the flaw in each problem and suggest a remedy. Okay, so in problem 24, a produce buyer for a supermarket is inspecting crates of peaches. He examines 20 peaches from the top of each crate and then purchases the crate if all 20 peaches are satisfactory. Okay, what's wrong with that? Well, the peaches at the top of the crate might not be the same quality as those at the bottom. So it could be that that the seller is on purpose putting the lower quality peaches at the bottom so that they're not seen. Okay, that could happen. So, if you're only looking at the ones that are at the top and saying, yep, it looks good, you might be making a mistake. A very easy fix to that, don't just select peaches off the top, okay, but select peaches throughout the entire barrel, okay? Be as random as you can, okay? Problem 25 says to determine the public opinion of the police department, the police chief obtains a sample of 15 census tracts within his jurisdiction and samples all the households in the randomly selected tracts. Uniformed police officers go door to door to conduct the survey. Okay, so what's wrong with that? If somebody's all dressed up in their uniform asking about the police department, you might not respond truthfully to about the police department if somebody's there all dressed up in the uniform. Okay, so a better idea would be to have the police officers not dressed up at all, or even even better, don't even have the police department involved. Okay, but have a neutral party go door to door and ask the survey. Okay. There's a note that says when analyzing the results from a survey using questionnaires, you should be sure that the questions are properly written, since the way that the questions are phrased or even ordered can often influence the way that people answer them. Okay, so let's take a look at problem 26 there, where it says, consider the two questions and determine which one is written in a more balanced form. Okay, so part A, do you feel that the North Huntington School District should build a new football stadium? Okay, and then part B, do you favor or oppose increasing school taxes so that the North Huntington School District can build a new stadium? Okay, well, I would say B is more, more properly written. By the way, do you favor or oppose doesn't automatically mean what one side. Okay, so by saying that, you're not presenting the question as if you are in favor of it. Okay, so I mean, like in part A, I mean, sure, who wouldn't want a new football stadium? Okay, but when you increase school taxes, maybe some people don't want that. Then, okay, and by giving them the choices there, they can choose either one. Problem 27. Consider the two questions and determine if the order in which the questions are asked will affect the survey results. Okay, so part A, who is your favorite actor working today? And then part B, what is the best movie you have seen in the past year? Okay, so does the order of these questions mislead the reader somehow? Okay, and the answer would be, yeah, it could. Okay, results could be affected since somebody could be led to only think of a best movie that has their favorite actor. Okay, what's the best movie that you have seen in the past year may not include your favorite actor. Okay, but because the question about the favorite actor was done first, somebody might be led to think, oh, well, now I got to give an answer that involves, my favorite actor in it. Okay. So sometimes the order of the questions matters. Okay. There's a definition there. It says that a sample of size little n from a population of size capital N is obtained through simple random sampling if every possible sample size little n has an equally likely chance of occurring. Okay, equally likely just means equal. Okay, so you're not being biased towards selecting, one individual or one group of individuals over another. Okay, in other words, it's like selecting names from a hat. Okay, and we're going to look at some other types of sampling techniques a bit later in the notes, but simple random sampling is the most basic design. Okay, and that's the one that we're primarily going to use, in this course. So as an example of that, in problem 28 here, says the following table lists the 45 presidents of the United States. It should be 46, by the way. So part A, we want to use a graphing calculator to obtain a random sample of size 5. And then part B, we want to use a graphing calculator to obtain a second simple random sample of size 5. Okay, so, one thing to indicate here is like if we want this to be random. Okay, we don't want any biased selection going on. So like if I really like Andrew Jackson, for whatever reason, I don't want to just automatically select Andrew Jackson. Okay, that's being biased. Now, if his name comes up randomly, then that's different. Okay, but we want to avoid any biased statistics. Now, the book shows a few ways to obtain a simple random sample. They got a table, a calculator, certain websites actually using a hat. Okay, I only care about using a calculator. Okay, and I'll show you how we get that. So this is the 84 model, and if I turn the calculator on, then hit math and go over to PRB up top, and then down to number 5 where it says rand int, and then I'll hit enter. And I want to enter 1 comma 46. Okay, since there's 46 presidents. So 1 comma 46, and then close up the parentheses. And if I hit enter, my calculator will give me a random number between 1 and 46. Okay, so these are the numbers that I got, from my calculator when I did this earlier. So I would go to, suppose 27 came up. I would go to the 27th president, who is William Taft. Okay, and that president would be the first one in my sample. Okay, and then I hit enter again. Okay, and if I continue hitting enter, all these different numbers come up randomly. But suppose the number 4 came up. Okay, then Madison would be the second one in the sample. And by the way, one thing that we have to do is we need to order the list, because otherwise, what do these numbers mean? What does 31 mean? Okay, if the list is not ordered, then step 1 would be to order the list. Okay, so 31 would be Hoover, 39 would be Carter, 17 would be Johnson. Okay, and that would be a group of 5 that came up. Okay, now suppose I want to use the graphing calculator again to get a second simple random sample of size 5. Okay, well, so I would do this again. Now, by the way, do I think that the same numbers will come up again? They might, but it's highly unlikely that I get this exact same list again. Okay, although I could. Okay, but so I basically go through this procedure again here, where I go math, over to PRB, down to number 5. This is rand int 1 comma 46, and then hit enter. Okay, so suppose that the number 8 came up on the screen. Okay, so the 8th president would be Van Buren. Okay, and then I hit enter again, and so 20, Garfield. He'd be the next one that came up. Okay, and now 4. The 4th president, James Madison, was in my first sample. That's okay. It doesn't say anything about not using the same number or anything like that. So if I get some of these same numbers, that's totally fine. Okay, and then 45 would be Trump, and then 24 would be Cleveland. Okay, and so this group of 5 would be my second simple random sample of size 5. Okay, and of course it didn't come up on my calculator, but I would disregard a number if it comes up twice, so that it has 5 different presidents. If I saw the number 8 again, I would just disregard that 8, so that I have 5 different numbers, in fact. Okay. So when you think of this, it's kind of like pulling names from a hat. I don't know what number is going to come up on the screen before I hit enter. Just like I wouldn't know what name I'd pull from a hat if I'm not looking. Okay, so that's key. Okay, I'm going to go ahead and stop right there.